Thank you very much for the nice introduction. I do feel at home here. And each time I come here, I speak about the new research line, and it's usually very insightful to have comments from people here. So I'm really happy to present this new research line, which is about diversity quantification in natural language processing. And it's not my own work, it's a joint work with 5 people who met in the UniDive COST Action called Universality, Diversity, and Idiosyncrasy in Language Processing. And more specifically in the working group 4, that is entitled Quantifying and Promoting Diversity. And it's an international collaboration of people who really met in this action. And there are people from my university, which is Paris-Saclay in France. And there's also Belgium, Israel, and Ukraine and Germany on board. And this is a work that has been submitted to TACO. We are waiting for the reviews. So diversity. It's something that has really gained tremendous importance in NLP these years, and which can be illustrated by these 2 diagrams. So you have here the papers on ACL Anthology since 1990 until July 2024, because this is when we collected the data. And so there are things that have, so papers that have diversity, all diverse, in their title or abstract, and the orange part is just in the title. Okay, so you can see that between 2015, this was not really an issue in NLP, and since then it grows tremendously. And you could say, okay, it grows because NLP is booming, right? So here are the number of papers, just the number of papers, but the same tendency is observed in the ratio of papers. So since 2015-16, let's say, the percentage of all papers on ACL Anthology that have diverse or diversity in the title or abstract is really like exponentially growing, right? So we see that everyone is interested in diversity. This is very likely due to generative models, which have had this issue at the beginning that a model was responding always the same thing to the same question, and this wasn't a problem, right? But of course, not only generation is important, and I will try to say why.
Units on the y-axis, persons.
This is the ratio of papers.
Ratio
of papers, or on ACL Anthology. So papers that have diversity or diverse in the title or abstract to all papers,
it's
right? Yeah, it's a fraction. Okay, and so this work popped up because when we were reading these papers, we noticed a huge problem, which is lack of formalization of what people actually mean by diversity. Everyone is talking about it, but we don't really know what they mean. So what we notice is disparate understanding of this notion, lack of unified vocabulary and framework, limited attempts to systematize this notion. So we found just 2 papers or 3 papers or so. And this means that compared to the previous slide, NLP very well fits to a citation that was from a paper from 2007, where someone called Stirling he originated from economy, but he looked at the notion of diversity in many scientific domains, including ecology, and he tried to propose a unified framework. And he said, first of all, there are many domains in which diversity is prominent in discussion, like here, right? Like here, but remains undefined or analytically neglected. And NLP really very well fits to this. And this is our starting motivation for this work. So the objectives of this work are to take steps, of course not solve all of the problems, but take steps towards a unified framework for quantification of diversity. So it's really our focus, how people measure diversity, right? And to do this, we take inspiration from fields where this notion has been is much more mature, has been theorized before and systematically analyzed, and most prominently it was in ecology ever since Darwin. spoke about diversity. So what we did, we reviewed these all 308 papers, which are orange here. We couldn't review all blue ones, right? Because this is thousands of papers. But we did review the orange ones, which have diversity or diverse in their title, meaning it should be the central notion, right? In the paper. And we took them from the past 6 years, which is the majority of all papers having this property. And we reviewed them from the point of view of diversity quantification, so really measures of diversity, right? And out of this mess that we encountered, we tried to make and merge a taxonomy so that we have a way to talk about it in a unified framework, right? So this taxonomy is organized along 4 different axes. Why people are interested in diversity, what diversity is measured on, so what are the objects of diversity, diversity of what, right, in NLP. Now, where it is measured, meaning in which stage of an NLP pipeline people are interested in diversity, and then how is it measured? So what are diversity measures used in NLP? And so we started from ecology and other domains where this notion has been discussed for many years, and it's a mature topic. So initially there were dozens of diversity measures proposed and applied to various species. It's of course about diversity of species, which became to be a major topic many decades ago, and the habitats. Then at some point these measures were narrowed down to those that were inspired from information theory, so mainly entropies and transformations of them, like Hill numbers, and many distance measures which underlie diversity were also debated over, and notably their properties were discussed, which is important for us. So, for instance, properties based on functional differences, like how many legs an animal has, and so forth, and properties based on phylogenetic trees of a species. Okay, and then at some point it became mature enough to propose a unified framework. So there were several proposals for that, so that approaches can be compared, and finally properties of the measures were also debated over, so that we actually know which measures are good for which context, right? So I won't go into the details of this theory, but just on a very high level, this theory assumes that there is a dichotomy between elements and categories. So elements, meaning individuals in ecology, so animals and so on, they should be able to be apportioned into categories. So we really need these two. Elements which are individuals in ecology and categories which are species in ecology, right? And once we have this, then the theory proposes to play different measures which can be roughly placed in 3 different dimensions. One is variety. I tried to translate it yesterday into Polish. I have no idea, but maybe we can just debate over it. So variety is basically related to the number of categories. So the more categories we have in a habitat, more species, the more diverse is the habitat, right? The simplest one. Balance is about the evenness of the distribution of these categories. So when you have a habitat, like a square of land, where you observe insects, right? And if you have one insect that dominates and the others are few, then this habitat is less balanced, so less diverse, than one where you have the same number of species, but their number of individuals is roughly the same, right? And finally, there's disparity, which is about the distances between species. So if you have a habitat with I don't know, cats and dogs and cows, this is less diverse or disparate than one with dogs and octopuses and flies, right? Butterflies. So, sorry?
This distinction between elements and categories, I think it corresponds to the distinction between tokens and types.
Yes.
In what is the difference?
Yes, exactly. Only in NLP tokens and types are overloaded.
Yes.
So we try not to use this term because people understand it wrongly, and we do use the notion of elements and categories. Okay.
Sorry, but disparity and disparity are very closely related. It's because it depends how you divide things into classes, and then you have more or less of this.
Yes. So theoretically, you could very well imagine something that is varied but not very disparate. But your intuition is great because we have been doing experiments for 2 years now, and it seems that in NLP. So I'm selling you the scoop, but I'm not talking about it today. But we are about to publish a paper which shows that in NLP, variety and disparity are so strongly correlated that it's actually useless to speak about disparity. Okay, but the first intuition is not like this, right? In an animal habitat, it should be important to measure disparity, and likely in NLP too, right? This is the starting point.
Just to clarify, so if you have, say, a habitat with many mammals, but not reptiles, or just mammals, that would be varied, but that wouldn't be
disparate.
Okay,
Exactly. Yeah. Okay. So far, so good. So these are, of course, not measured. These are only dimensions along which we can place different measures. Okay. And now, now I come to this taxonomy that we proposed studying these 308 papers. It looks like easy. It took us 2 years, 5 people reading these papers for 2 years, which is a lot of work. But here's what came out. So why? Why should diversity matter in NLP? We can. It's not very easy to always say because some people just don't mention why. They just imagine it's obvious. But we can deduce from these papers more or less what the motivation is, right? And these motivations, whenever explicit or deducible by us, can be roughly positioned along 2 axes. One is goal versus means, and one is ethical versus practical. So on the crossroads between goal and ethical, you can see approaches where people say, oh, we want diversity. This is the aim, right? This is the goal. And we want it because it's better, because it's ethical to have, for instance, many languages in a dataset, right? Now, when you go to the right here, people will show that that diversity is important because users expect it. Because now that LLMs have come close to the performance of human performance, people say, oh, human language is diverse, so I want language models also to be diverse. So this is, the goal, but for practical reasons. If a chatbot always gives you the same answer to the same question, the user is going to be bored in 5 minutes. So it's, it's not going to come up to user's expectation, right? Now, when you go down this axis, you will have approaches where diversity is not a goal, but a means to achieve a goal. And this can be for deontological reasons and best practices. I will show you examples of that. And then finally, and very often, and this is probably the majority of approaches, people want diversity because they see that it makes performances grow. For instance, if you have a more diverse training corpus, then you will have better scores at the output, right? Okay. And now some examples. So let's take this first cell here. Diversity is a goal, ethical goal. So this is a large number of papers where people notice that there's an issue with overwhelming dominance of English, that there are under-resourced languages and endangered languages. Every 2 weeks, one language disappears, and so on. So they promote diversity because they want digital inclusiveness. They want NLP to equally serve users. So equality is important. They want to represent different languages, families, scripts. They want to fairly account for different cultures. Okay. And also they want a variety of topics. So if they use NLP for teaching, for instance, the different topics should be able to be addressed. Okay, so now let's go to the diversity as a means to achieve an ethical goal. So here, for instance, people show that if you train your model, question answering model, on diverse prompt response pairs, then this model is less offensive. So so LLM answers are less offensive. Okay. If you make sure that in your transformer, for instance, you have diverse attention vectors, you can manipulate them so that they become diverse, then this model is not that sensitive to adversarial attacks, you know, that fool it towards giving incorrect answers or towards not filtering aggressive questions. Then people also show that if you have diverse benchmarks, then evaluation in NLP is more reliable. Of course it is, because it addresses data sets that are out of domain, right? Possibly. So if your system is better in an out of domain context, then of course it's better, right? But for this to be shown, you need benchmarks that are diverse. So out of domain performance is one concern. Then highlighting the remaining challenges is also another one. And people also showed that sometimes it's better to have a more diverse evaluation data set than a bigger data set. Actually, quite often. Okay, so this was this cell. Now there is the practical goal. And so, for instance, people say, yes, I told you, because diversity is considered to be an inherent property of human language, users tend to expect the same from models today. And so models have to be diverse, right? It must be a goal. Another interesting problem that emerged relatively recently is what is called one-to-many scenario. So in generative models, for instance, now, or in translation models, people no longer want one translation for one source sentence or one response to one question. They want one-to-many, right? And this means the output must be diverse, not always the same. Another example is sorry, here's an error. This is the one I already told you. In dialogue systems, it shouldn't always be the same answer. And also we see that in evaluation of NLP models, more and more often models are compared to human performance, also for diversity. So implicitly, we consider that diversity in human language is an upper bound for what models can achieve, right? And now the last type of motivation is here. Diversity as a means to achieve a practical goal. And we have many examples from performances which grow because the training corpus is more diverse in different domains: parsing, generation, translation, and so on. Then people also show, oh, it's not necessarily the training data that has to be diverse. It could be something in the model. So for instance, instead of having one model, you can have an ensemble model. And if these submodels are diverse, then the performances are better for the whole model, right? And then they say, oh, let's think about classification. If you have names of classes and these classes are also accompanied by labels that kind of give you major topics inside a class, then if these keywords are more diverse, then classification is better, for instance. Of course, heavily people look at the quality of generation, and there again, if they want the generated output to be diverse because it's less generic and more informative for users. That's what user experiments show, and so on and so on and so forth. So it looks like there are really many reasons why diversity should be important in NLP. And now that we know it, we can also see, we can take a step back and look at all these tendencies. And what we see is that most works don't even ask the question, so do we want diversity or the opposite, right? They mostly assume that, of course, diversity is good. But some of them note that actually it depends on the context. So they would say, for instance, if your question answering model is about asking factual questions, like about dates, places, numbers, and so on, you don't want diversity. You don't want the models to invent, right? You want precise question. Maybe it can be formulated in a different way, but the contents is basically unique. I mean, more or less unique, right? So you want low diversity. But if you have a model for storytelling, this is where you want creativity, so it means diversity, right? So it all depends, right? Yeah.
It's a bit more subtle because here diversity is equated with randomness, and we can ask whether randomness is a sufficient cause for diversity.
Of course, it probably isn't, but
it probably isn't.
But
diversity is something more subtle than this, than simply randomness.
Definitely. Now, if you agree that some measures are diversity measures, of course they will be closely connected to probabilities, and notably balance measures, because it's about distributions, right?
I think it's difficult to say something is needed or not needed before we define what diversity is.
Exactly. That's exactly the problem. Okay, so yes, and there was this idea, but some time ago already, that maybe it's good that models are not that diverse, because this would allow us to distinguish model-generated data from human data. But these days are kind of back. It was the last paper we saw was 4 years ago, I think, and yeah, it looks like it's not really that much a hot topic today to maintain this difference between LLMs and human language. Okay, now another thing that pops up quite often is this trade-off between quality and diversity. So it's like precision and recall. Very often you cannot have both, and you want a trade-off between the two. So basically, for instance, in generation, if you allow more diversity, you encounter the risk of being less accurate, right? So very often you will have to choose the level of accuracy of your answers as compared to the level of diversity. Not always, but sometimes. And then in very few papers, people actually try to ask the question basically, so what is diversity, right? So this theorizing aspect is present, but in very few papers. So some people try to explain, so what is typological diversity? Because many papers actually say, oh, we are good because we address typologically diverse languages. And no one says what it means, right? So there are attempts to answer this question. Then some attempts to make educated choices of diversity measures. And then some comparative frameworks also popped up, but very few. And our work is precisely in this group. Now, let's go to what. So we answered the question why. Now, what diversity of what is measured in NLP? So we saw emerge 3 different categories of objects, so categories, right? Of which diversity is measured. categories, yeah, and sorry, I have to say there's a caveat, because these categories are never named as such by the paper authors, because they never refer to the theory of diversity. So they don't say my categories are these and elements are these. We have to read the paper and understand from the paper what are categories for them and elements, right? So there may be issues with this. Some papers are very bad quality. Some papers don't explain much. They have issues with formulas and so on. So maybe in some approaches, our conclusions were not the correct ones, but we did our best. Okay, so these three types of categories are the following. One is in-text diversity, meaning categories concern parts of text. So for instance, unique words, unique anagrams, sentences, syntactic trees. These things, when they are categories, they are called in-text categories in our taxonomy. Then elements would be occurrences of these unique words, of these anagrams, of these sentences, of these syntactic trees, and so on. Okay. The second type is meta-linguistic diversity. So elements could be inside text, and often they are, like text, language, words, and so on. But the categories are metadata of the text. So the language family, a branch in the language tree, a genre, a domain, a time period, a cultural feature, or whatever, right? And finally, what we call diversity of processing concerns everything that happens inside models. So, for instance, if inside models or during the process of creating language resources. So, for instance, if they say we are using diverse annotators, I mean, not using, but different diverse annotators participate in our annotation process, or we use diverse submodels in an ensemble model, or we look at diverse NLP tasks in a benchmark, or our evaluation metrics are diverse, or attention vectors inside the model are changed so that they have become diverse. So this is all diversity processing. And in this category, very often people are kind of, they easily use the notion of diversity, meaning a few already means diverse. So this was what, and now where do people measure? Because it's about measurement, right? Where do they measure diversity? Where we try to define domains, but this is imperfect. You know that defining domains is a very hard topic. So it is, of course, not perfect, but still we see tendencies. So generation is the point where diversity becomes really crucial. And the booming of generation is precisely the point when the number of papers grew so much. Now, corpus creation is another one. We have classification, dialogue, machine translation, and so on and so forth. Many of them are, of course, interlinked. So these numbers have to be taken with a pinch of salt. And I'll come back to it. And now, where is also about at which point of the typical NLP pipelines diversity is quantified. And we, in a very simplified way, we define these stages. So we have the system construction here, often training or fine-tuning, input data here, output data here, and then on the beginning, we have the data collection. So for instance, what languages we take, from which domains, from which sources, and so on, which genres, and then how do we annotate them? And then at the end, how do we evaluate the output data? So these are the different stages. And when we look at the papers, we classify them into these stages, we cast them on these stages, we see that there are only 197 out of 300, remember, that actually quantify diversity. So meaning 300 papers have diversity in their title, but only 2/3 actually quantified, right? And out of those, in all those 200, there are 150 diversity measures. They all are called different. So you see the problem, right? All this is not comparable. Unless you really dive deeply into every paper and you try to say, oh, he or she speaks about the same measure as this one, right? So this was really hard to, no, sorry, I missed something. Yeah, okay. I didn't actually comment on this slide very well, because what is visible here is how many papers measure diversity in each stage. So we can see that the majority is on output data. So what is the diversity of the for instance, generated or annotated data, and how do we collect data? And this will come in the last slides again. Now, yeah, so these 150 different diversity measures, we tried to group them into classes. And we found, first of all, 3 different approaches and then 9 families inside this approach. The first approach, the first type of approach is absolute quantification, meaning that, I'll come back to this later. Absolute quantification meaning is that we have an observed set, for instance, a set of generated sentences from a model or a corpus, and then we want a number, an absolute number, right? What is the diversity of this set, observed set? So the parameters we look at are the numbers of categories, which we have to identify in advance, the number of elements apportioned to these categories, the distribution of these categories. So what is the proportion of basically frequency of every category, right? And then this is a distance matrix for pairwise distances between categories, okay? Okay, so now the absolute quantification is the most frequent one. And there are many, many types, but we will show like most typical ones. So one family is what we call quantity. This is a very simplistic approach. Most of the time, the people say, oh, we are diverse because we address 5 languages, okay? And richness, so the number of categories, is indeed a very frequently used diversity measure. And this can be, there can be variants of this, but most of the time it's just n. Many papers measure diversity like this, and we were very actually nice to say that if a number like this appears in the paper, there is a measure. You see, so it's a very like tolerant approach. Now the second family is what resembles type token ratio. So the number of categories divided by the number of elements. And there are many variants of them. The most popular one is what is called dist-n or distinct n or diverse n, which is basically the ratio of distinct n-grams, so n being 1, 2, 3, or 4 most of the time, to the total number of tokens, so words, right? It's a variant. And it's very, very often used, but we found, not only us, but there are issues with this measure. One of them is that it's not monotonic to n. So when there can be 2 different subsets with one having more categories than the other, but the diversity being opposed.
Another problem with type token ratio is that it depends on the text length.
Yes, exactly. That's precisely the reason. Another family is a family of entropies, not that very often used, although information theory should be, very present in NLP, but it's not that present in the diversity aspect. Entropy is, as you might remember, a sum of these products, the probability of the if category, multiplied by the log of this probability. And this is this encodes the surprise of encountering an element of the if category, right? So this is monotonic with n, so the number of categories, and the maximum value is when the distribution is uniform, so every category has the same number of elements. That's why it can be classified as both variety and balance, okay? And then we have the distance, d-distance family, which is basically an aggregation of pairwise distances between categories. So the most simple aggregation is like this. So we have this matrix of distances between categories, and we multiply, we sum all the all the distances, and we divide by, so basically it's the lower left-hand triangle part of the distance matrix, right?
Average distance.
Average distance between categories, right? And there are variants of it that are more or less similar to this. One other interesting type of the distance is when people look at vectors, so for instance, embeddings of their words or whatever sentences, and then they take the volume of the geometry occupied by these vectors, by the edges of these vectors, right? So this is often made by a convex hull, and it's another type of this distance because it's basically an aggregation that is specific to this application. And then entropy of distances is also an interesting example. And of course, the distance can be of any type, right? So we notice very frequent use of two particular distances in this family. One is the blue measure, and one is the BERT score. So blue is something you know from machine translation, and it measures the quality of of a translated text by comparing it to a reference translation, right? So you want the BERT to be high, so that similarity of this text is high. And here in diversity-oriented quantification, people divert this measure to mean the opposite. So they define self-blue by the following. Let's have many sentences. We have a data set with many sentences, and we compare blue score of each pair of sentences within this data set, right? That's why self-blue inside the same set. And now we want this to be high. We want this to be low because we don't want sentences to be similar. If they are not similar, they are more diverse, right? So this is basically an average blue, not similarity, but distance between sentences. Okay, fine, good. And another example is the BERT score. So BERT score is what they call precision recall and F measure on vectors. So you have two texts, let's say sentences X and Y, then X1, X2, X3, and so on are words in these sentences, Y1, 2, and so on are words in the other sentence, and then these are embeddings of these words in these sentences. And you simply take a product of those embeddings which are the most distant, the closest, right? So this is so this is what is called recall of one sentence compared to the other, and precision is the opposite. And then you calculate the F measure. Okay, almost there. So you can notice here that what we are trying to do is to cast these families of measures on the theory of diversity from ecology. And I skipped this slide because I wanted to come back to it later. But you see what we do next is that we take these families and we say, oh, there's the Venn diagram of the variety, balance, and disparity, because measures, as you saw with entropy, can be both one and the other, right? So entropies, for instance, are both varieties and balances. And now we take these families of measures from NLP and we cast them on this diagram. And you can see, for instance, that TTR is not inside because it's not monotonic within, right? So we don't think it's a good variety measure. Although we don't know because it has never been defined what is variety in NLP, right? This is our next step, but this is, let's say, the intuition we want to have. Okay, the distance family is, of course, disparity, and the blue and the BERT are inside this family. Now let's go to the second type of quantification, which is not absolute, but which is relative. So relative quantification means that we now have two sets, the observed set and the reference sets. And there can be two scenarios. Some people say, okay, I have a data set, a corpus, for instance, which people carefully curated to be diverse. They were linguists, they know which languages are diverse, they know which domains are diverse, and the reputation of this data set is to be diverse. And now I construct more or less automatically another data set, and I want it to be as close as possible for the distribution for my categories as this reference set. If it is close, then it is diverse, right? Another scenario is the opposite. It says, okay, I have a training corpus, and now I have a generative system, and I would like the system not to generate the same sentences as the training test, right? So the output is diverse if it is very far away from the reference set. You see? Okay, and in this context, we saw two different families of measures. One is distribution. So basically, we take the cross entropy. So it's like entropy, only the probabilities here are across, right? So it's the probability of the each category of the reference set multiplied by the probability of the observed set, right? And the other one is overlap. So this is simply a Jacquard measure of the sets of categories. So we want the number is high if many categories are common between the two sets, right? Good. Now you can see that none of those belong to the theory of diversity, to the Venn diagram, because so they are here. Because in ecology, this problem was never proposed, never modeled this way. Maybe there are such problems, but they are not called diversity. Okay?
It's a problem of the niche existence for new species to fill it.
Oh, maybe. We'll talk about it because I'm not sure, but it's interesting. Okay, and then and yeah, so this was relative quantification, and the last example is introspective quantification. So people think, oh, humans will know what is diverse. So what they do is they give them samples of text, and they either need to be ranked. So this one is more diverse than this one, or they are to be positioned on a scale from 1 to 5, for instance. And we also put these measures outside of the Venn diagram because there is no evidence that humans will actually think about categories and elements to decide if something is diverse or not, right? Okay. And finally, a discussion, and I have several slides, but maybe I won't say everything because it can take hours. This discussion is the most interesting. So of course you saw that diversity is prevalent in NLP, right? This is quite obvious. And now the problem is that it is used informally. So just to give you numbers, 28% of these papers, of these 300 papers, judge diversity important. It's in the title, but they never define it. Further 20%, you cannot say they define it, but they give a number. It's the number of categories, right? And then many, very often, because they have a few categories, not just one, they say it's diverse. If they use measures, if they do quantify something, they never say why this measure. Why should it be good and bad for my application? So the properties of these measures are never discussed and never compared. And in many cases, papers are unclear and measures are unclear. And even going back like 5 steps back to the original paper, even there you don't really understand how it is measured. So the quality, at this occasion, you also see the quality of ACL Anthology going down, actually. And also, not only it's informal, but it's inconsistently used across papers. So we have these 150 different diversity measures, names actually, but many of them are similar or the same. So people call the same thing different names, or they use the same name to call different things. And they don't seem aware that diversity is a very mature concept in other domains. They just don't look at it, except very few papers that did look at it. So, and they never, or hardly ever, there is one paper in ours, refer to variety, balance, and disparity. But what is interesting is that we could identify two majority scenarios in the whole bunch of papers. One scenario is about corpus creation. So what people say, okay, diversity will be quantified at the stage of data collection. We need to look at diversity because we need to ensure inclusiveness and equality, so it's an ethical goal, or we have to ensure performance, so it's a practical means. Then the categories are most of the time meta-linguistic. So these are text genres, languages, language genera, language families, cultures of the text, and so on. And the measurement is most of the time just variety, so quantity basically. And the most, let's say the most impressive maybe example is when there are really many languages and many language families and many genera and so on. These are papers of the type like Villamova, who look at computational psychology, and they try to generate inflected forms for many languages, and this goes into hundreds, right? But many other papers are much more modest as to diversity. Now, another scenario is kind of opposite scenario, is the generation scenario. The quantification of diversity happens at the output stage. So the generated data, right? It is measured because it is a user expectation or naturalness expectation to be diverse. So it's a practical goal. And one example is that we want to enhance chatbot responses, and we want these responses not to be always the same. So there is a one-to-many scenario because users expect it, right? Now, the categories are most of the time in text categories. So, sorry, this is a copy-paste problem. This is, of course, not genres or languages. It's most of the time n-grams. Right? And now, the way it is measured is most of the time either type open ratio or distances of all kinds between sentences. And an example of such a scenario is when you want chatbots to have diverse and both diverse and relevant responses, and the way people do it is that they look into the model and they add some latent variables or change something inside so that what is generated is not one optimal answer, but something more. Right? And do I still have 5 minutes? Yeah. And then when we go further, we can ask the question, okay, so is diversity something like naturalness? What is the relationship? Because this pops up in the papers. And we saw that there are two opposite contexts in which these two notions could be compared. In one scenario, in scenario one, the one that I explained with data set collection, it looks like naturalness and diversity are opposed, because arguably that one language dominates is a kind of natural process in the sense of, you know, the strongest, the best, right? And now we create this data set in such a way that we balance this dominance. So we go against this naturalness, right? In scenario two, it's the opposite, because diversity is expected to be an upper bound for system models. Diversity of human generated text is this upper bound. So diversity and naturalness are considered positively correlated. And we can also reason about the naturalness of the categories, because these are the basic, how do you say, stepping, the basic items of diversity measurement, right? in many papers, these categories are natural in the sense that they are linguistically motivated, like words, idiomatic expressions, sentences, syntactic trees, and so on and so forth. But sometimes they are not. Often they are not, like n-grams, word pieces in BERT, word embeddings, attention vectors, points in a vector space, and so on. So these are categories that are not linguistically very motivated, but they are most often approximations of linguistic notions, and the diversity is easier to calculate simply for these unnatural categories. And finally, let us note that, yeah, we could think, so why don't people in NLP care about what diversity means in other domains? Probably it's just because they don't read, but maybe also because there is a difference in how we do science, basically. So what we can observe in 28% of the papers is that they use DBLE or DBERT, so the disparity measures. They apply them directly to sentences or to texts, and there is no notion of category. So in this way, you could say it's a kind of trivial disparity where categories are equal to elements, right? They compute distances between two sentences like as if they were categories, but they only occur once. Okay, and then if this is the approach, then of course variety is trivially the data set size, and balance is moot, right? There's no sense to think about balance because there's only one occurrence of each type, of each category. And thinking about it, we can notice that, of course, NLP now goes more and more towards continuous representations, and they are very much like considered efficient representations. If you have continuous representations, how do you make categories emerge? This is not obvious, right? You could think of clustering, but it's not that easy.
Yeah. This has to do with novelty detection, because the richness can be defined as the number of novel elements. The total number of novel elements would be the richness. And then you could try to define a new novel element that is sufficiently distinct from the previously seen ones.
So what is novel? It's something you've never seen?
Something that you've never seen, yes.
Like a word you've never seen.
Like a number that was never seen.
Yes, and then this would be a category, yes. Yeah, so when you look really at words or word pieces, you can, but
vectors. But for instance, vectors. What is a new vector?
Yeah,
it's a vector that is okay. This has to do with clustering a bit, but this clustering should be done online, as you have more and more.
Yeah, exactly. But on the other side of this scale, of course, when you think of ecology and species and individuals, you see that this is this traditional way of doing science, where creating categories is a basic scientific process, right? You go up and you see these categories emerge. That's how, I talked to a student who is a philosophy student, and he said this all goes back to ancient Greece, when who said that? I forgot who defined how science should be done, and this was by categorizing things that are surround us. So maybe one of the reasons why there is so little popularity of diversity theories from ecology and other domains is that we no longer want categories. I don't know. That's how I would like to finish this presentation. And thank you very much. And I'm happy to answer questions.